Okay, I'm gonna your question for meeting you. Awesome, that's fine. So great. Good evening, everyone. Welcome to week two, and we're having the first lecture. And I'm so super excited to be in the class as well and to relearn a lot of stuff. And we're happy. Our CTO, etc. It's his live and direct, and he's going to take us deep dives technically and a whole lot. So I want you guys to be tuned. Open up, feel free, ask questions, do your research, continue the conversation on Telegram, on the classroom, so I can motivate others. And mind you, on the Telegram, we have a lot of people on the Telegram. We have people from the Ethereum Foundation, people from the Graph, people from Ficon and stuff like that. So this is like potential prospects and for internship and stuff like that. So just be creative and position yourself. So, Metete, great to have you, and over to you.
Thank you very much. Good evening, everyone. Welcome once again to the Ethereum Nigeria Bootcamp week 2. Our first lecture, of course. Today, we are going to be looking at smart contracts and their role in Web3 space blockchain. So last week, we looked at blockchain. We understood the major components of blockchain. So this week is a follow-up of what we discussed last week. Basically, last week we established the importance of blockchain, how blockchain has changed or revolutionized the way we interact with the digital world. So, but the question lies at the heart of all this, and we discussed blockchain, but how does it work? Like, for instance, if person A sends cryptocurrency to person B, we established that the blockchain is decentralized, it's safe, it's secured. But what really happens under the hood? So under the hood, at the very core of blockchain technology, it's smart contracts. So smart contracts are basically the engine room that powers the blockchain. So for our first example, says person A wants to send money to person B. It is actually a smart contract that actually executes this transaction. How does it do this? I'll share my screen now. Okay. I'll share my screen now so that okay. I hope everyone can see my screen, yeah? Okay.
Yes, we can.
Okay, all right, awesome. So, like I said, last week we looked at the concept of blockchain technology. So we asked ourselves, we established the fact that blockchain is safe, secure, transparent, and decentralized. And earlier I mentioned that at the core of this very blockchain are smart contracts. So smart contracts are basically lines of codes with terms of agreement written into this line of codes. Basically, what this means is that, say, person A and person B wants to do a transaction. So this transaction, just like a normal transaction, this transaction is written in a contract, just like a normal contract we execute daily. Say you want to buy a piece of land or you want to buy a car, you are issued a receipt. So that's kind of like a contract that you actually paid for and own the car. So, but the difference is that smart contracts are digital contracts. They are self-executing, meaning that they are automated. So basically what the smart contract does is it checks the condition of the agreement between party A and party B. So if these terms of agreement is met, then whatsoever was agreed upon, the smart contract executes it. So in the example of person A sending money to person B, so if person A says, okay, I want to send, for instance, 5 Ethers to person B. Now remember, Ethers is the native token of the Ethereum blockchain. So person A wants to send 5 Ethers to person B. So what happens is that there's an agreement that, okay, once the person A press send, the smart contract in which this token, the Ethers token was deployed on the blockchain, which we'll look at later. So that smart contract actually checks, does person A has this amount of money to send? Okay, if he has this amount of money to send, deduct it from his balance, credit it to person B, increase, update the balance of person B. So basically, the smart contract takes care of all of this. So like I mentioned, I need this to go. Okay. So like I mentioned, a smart contract is a self-executing contract with the terms of agreement written directly into the code. Like I mentioned, yeah, the agreement is written directly into the code. So it becomes a question of how does it work? I'm a very curious person, so I would ask the question like, how does it work? So under the hood, remember, the blockchain is a decentralized system, meaning that it's made up of multiple computers. And we understand that computers only understand zeros and ones. Computer doesn't understand the text you send inside or input, but it understands zeros and ones. So smart contracts are actually written in a particular programming language. Now, once these terms of agreement between person A and person B is written using the various smart contract languages we have, this smart contract is then compiled. Now, the compiler actually converts converts this agreement that is written in human readable form into zeros and ones that the Ethereum virtual machine can understand. So basically, it takes the functions from these smart contracts and it checks if the conditions are met, then it executes another function. So basically, smart contracts are self-executing because they live on the blockchain. So automatically, they are decentralized. We'll look at all of that in a bit. So like I mentioned, the code facilitates and verifies and enforces negotiations or transfer of value between parties. Yeah, just like I mentioned before, the smart contract actually ensures that the agreement is adhered to. The agreement that was compiled and deployed on the blockchain is actually adhered to. So before we proceed, let's look at how the smart contracts come about. Okay, a brief history of how smart contracts came about. So the idea of smart contract was initially proposed by an American programmer named Nick Szabo in 1996. Actually, his concept was that smart contracts, which are of course digital protocols of information, would actually excuse me, sorry. So, like I said, sorry, Szabo said that according to Szabo, his conception of smart contract was that smart contracts, being digital protocols for information, can transfer information using mathematical algorithms to automatically execute the transaction once the established conditions are met. Now, that was what he proposed in 1996, but then he had a problem because also in his paper, he did also mention that the smart contracts would be efficient on a decentralized system, on a distributed ledger, which of course is a decentralized system. So the problem at that time in 96 is that the concept of blockchain was not fully implemented. So there was no way he could actually test this concept until 2008, of course, when Bitcoin solved the problem of distributed ledger. But then the challenge with Bitcoin was that Bitcoin did not make provisions for smart contracts. So 5 years later, Ethereum came out, and Ethereum was specifically designed for smart contract and every other transactions. So basically, Ethereum is the father of smart contracts in blockchain technologies. That's why even up to today, many protocols rely on Ethereum. We'll look at all of this in a bit. So let's look at then how how the smart contracts work. Like I mentioned before, the terms of the agreement are written in the code. Then the code is compiled. The compiler translates these terms of agreement into zeros and ones so that the computer, the Ethereum virtual machine, can understand. And then functions from these smart contracts. Functions could be like agreements, right? Because after deploying your smart contract on the blockchain, you can actually interact with it. So, for instance, when we say person A sends money to person B, when person A goes on his device and enters a specific amount and press send, it's actually interacting with the blockchain. So it's calling a function in the smart contract. Probably the function could be like maybe pay or send. You understand? So it's calling the person A is calling a function from the smart contract. So once this once you call the function in that smart contract, of course, the function is going to check. This check now is the terms and conditions of the smart contract, the agreement between the two parties. So it's going to check, does this person have this amount of money to spare? If the person doesn't have this amount of money to spare, revert the transaction. Not just in sending money. Let's look at another example, say like an e-commerce site. Something like Jumia, right? So the traditional Jumia now is you prepay, like you see an item you like, you pay before it's being sent for delivery. So basically, with a smart contract, we could tweak our agreement, right? We could say, okay, I'll pay this money, but it will not get to you until I receive my product. So basically, the smart contract now acts like an escrow, so that when you pay the money, Jumia actually can verify that you've paid the money, but the money doesn't get to Jumia until you receive your product. So it's just the terms and agreements that is being agreed upon. So the smart contract, which is of course self-executing, basically just ensures that the agreement between party A and party B is adhered to. All right, so let's look at also the key characteristics of smart contracts. So like I mentioned before, one of the key characteristics of smart contracts is that it's decentralized, meaning that it does not stay on a particular, on one server. So smart contracts basically live on the blockchain. So that means that not one person controls it, right? So even if a server A is down, there are a billion other servers that can function at the same time. So this decentralized nature of smart contracts actually promotes transparency, because once a smart contract is deployed on the blockchain, just like a user has your like we saw last week, we created our wallet address. So just like a user can create a wallet address, remember your wallet address is like your space on the blockchain where you can actually send and receive information and tokens and every other kind of thing and sign transactions. So that's your space on the blockchain. So every smart contract actually has an address, just like your wallet address. So this address is where is the smart contract space on the blockchain, meaning that it is distributed among all the nodes that make up that blockchain. So I also mentioned automation. Automation means that the smart contract is self-executing. Once the terms of agreement between party A and party B has been met, as described on the smart contract, the smart contract executes the next function. If it was to send money to party B, once it checks that party A's balance can actually carry out that transaction, it sends that transaction. But if party A's balance is not up to or is lower than the amount party A is trying to send, of course, the transaction will revert. Revert means that the transaction will not be verified on the blockchain. It will not go through. So immutability, yes. Remember that anything stored on the blockchain cannot be changed. So once a term of agreement has been agreed upon, once the smart contract has been deployed on the blockchain, it cannot be changed, meaning that you cannot go back later to try to edit any function or edit anything. It's not possible. So they are very, very immutable. That makes them very, very safe and secure. that makes them also very, very trustful, because you can trust that even if you don't know party A, or even if you are carrying out them, okay, let's say for instance, like I mentioned, the e-commerce side, Jumia is a brand that everybody knows. So what if a new brand comes up that we are not familiar with? Of course, you would not want to go and buy things on a website you are not familiar with, right? So, but imagine if this website runs on a blockchain. You don't need to know who owns the website. You just know that whatsoever terms of agreement that you agree and is being put down the smart contract and is deployed on the blockchain. For instance, if you say, when I buy from you, I will pay you, but I don't want the money to get to your wallet until I receive my product. So once these terms of agreement is met, until you receive your product and verify that you received your product, once you verify you received your product, of course, the blockchain now the smart contract, automatically sends the money that you paid for now to Jumia. So the immutable nature of smart contracts make them very, very safe and trustful. You can trust that it will not be tampered with. And another thing is that it is very, very transparent. Yeah, like I mentioned, every smart contract has an address. Of course, like we saw last week, all you need to do is get the address of the smart contract, go to any blockchain explorer. Specifically, you are familiar with Etherscan, so you can just go to Etherscan with the address of this smart contract. Once you search it there, it's going to give you all the activities of the smart contract. So it's very, very transparent, it's verifiable. And these are some of the key characteristics of smart contract. Before I go on, I don't know if anybody has any questions so far. Okay, in the absence of question, I'll just continue. So we look at some use cases of smart contracts. So why do we need smart contract? Remember I said that smart contracts are...
Yeah. Since someone is raising up their hand. Okay. Nicholas, are you the one?
No, sir. I'm just saying that I'm following.
Okay, awesome. All right.
Okay, that's awesome. All right, so we're going to look at some of the use cases of smart contracts. Why do we really have to pay so much attention to smart contracts? We need to, because smart contracts are basically the engine room of blockchain technology. Every protocol, every decentralized application, every token you've seen, every coin you've ever come across, those are all smart contracts. Those are all smart contracts with terms and agreements written into them. Now, depending on the ecosystem, the terms could be different, but basically all of them run on smart contracts. So one of the use cases of smart contracts is, of course, in the supply chain management, the example I gave before, where if you want to order something online, you pay for it, but the money doesn't get to them, or the smart contract holds the money until you receive your product. Once you receive your product and verify that you received your product, then of course, the smart contract releases this money to them, to the seller. But in a situation where you do not receive your product, the smart contract reverts your money back to you. So on the supply chain management, of course, the smart contracts are very, very useful. Also, insurance companies, of course, can rely on smart contracts to automate claim processing. Of course, this will reduce fraud and provide more accurate premium based on real-time data, meaning that this insurance company can actually have their terms and their conditions infused in a smart contract, right? So that, for instance, let's look at the agricultural sector. Let's say farmer A insures his crops for maybe 100,000 naira. Now, the insurance company being a decentralized community, a decentralized application, of course, says, okay, this is the term and condition of this insurance. If, for instance, we have drought for a certain period of time, then we can pay you compensation of 500,000, for instance. So now you might ask, how would the smart contract know when it's drought and all of that? Of course, there's what we call oracles in the blockchain. These oracles basically help the blockchain by providing verified real-time information that can be used on the blockchain. Remember, the blockchain is immutable, so anything that goes in there cannot be changed. So oracles basically verify all the real-time information that is passed to the blockchain. So they can use this technology, of course, to know that, to verify that, okay, at this certain region where this farmer claims there is a drought, was there really a drought? If there was a drought, pay the farmer the compensation. And the good thing is that nobody controls the process, right? So everything is automated. There is nobody that will stay that will want to say, okay, let me sign off on this payment. Everything has been infused in the smart contract. So automatically, if the condition is met, the smart contract actually executes the next function. So of course, we can also use it in voting systems. Yeah, we can also use it in voting systems. Of course, if we, for instance, want to use a smart contract in a voting system, of course, the contract would, of course, first verify that you are actually eligible to vote. So if you are eligible to vote, then you can cast only one vote at a time, depending on the election, whatsoever election it is. If it is multiple elections, maybe for a particular one, but you need to cast only one vote. So in the smart contract, you verify if you are eligible to vote. Then if you are eligible to vote, you are approved to cast only one vote. And remember, since it's on the blockchain, this process cannot be tampered with. So we can have a completely fair and free election using the blockchain, of course, with the help of a smart contract. Also, most decentralized finance also rely heavily on all decentralized finance, all of them, they rely heavily on smart contracts because it's a decentralized system. So when we're talking finance, of course, we're talking about money, movement of money, buy, sell. So imagine a system where everything is automated and is decentralized so that there is no central authority that is actually signing up on who buys and who sells. I'll give us an example. For those of us that are familiar with exchanges like where you take your cryptocurrency and you go there and you sell it for cash. Those are exchanges. Like, for instance, Binance is an exchange. We are mostly familiar with Binance. Coinbase, of course, is an exchange. So imagine taking your coin to, okay, let's say, for instance, you have Ethereum and you need to maybe make a transaction in Bitcoin. So now you go to an exchange like Binance, and then you make an order that, okay, Binance, I have Ethereum, but I need Bitcoin. So Binance then gets your money and then gives you Bitcoin, of course, with a fee. Now, the problem with that is that we have to trust that every time we need this thing from Binance, Binance will be able to deliver. But there are decentralized exchanges where you don't have to worry about the middleman. So an exchange like Uniswap, of course, if you have like in our example, you have Ethereum and you need to do a transaction in Bitcoin. So you can go to an exchange like a decentralized exchange like Uniswap. Now, Uniswap is decentralized and the process is automated. There's no middleman in between it. So you just go there, input how many Ethereum you would want to swap, and they give you immediately credit you with the value of that Ethereum in Bitcoin. So it's a completely decentralized system. So every decentralized finance platform to lend money, borrow money, swap tokens, even to build cryptocurrency, to create or build cryptocurrencies, all of these stuff are all smart contracts. Of course, I mentioned cryptocurrencies. Sorry, did somebody say something? Okay, so of course I mentioned cryptocurrencies. Of course, I also need to impute here that smart contracts are actually the engine room for tokens and non-fungible tokens, NFTs. So basically, tokens are what we call cryptocurrencies, coins. So for instance, Ethers, Bitcoin, a lot of them, they are all smart contracts that actually has particular terms and conditions attached to it. So there are many use cases of smart contracts. You can use smart contracts, of course, in our health system. You can use smart contracts in our education system. So there are vast in the education system, of course. Imagine going to, for instance, a university, and from your admission process, all your admission process up to when you graduate, all those processes are decentralized, meaning that you don't have to go to one office and be walking around up and down. If it's decentralized on a blockchain, which of course the information can be verified, you can easily just, for instance, if you have to do a clearance, you go on your school platform. Of course, since it's decentralized, every information can be verified. So whatsoever criteria your school needs for that particular clearance, the smart contract just checks all of them. Did you do this one? Did you do this one? Okay, if you did this one, you're eligible to be cleared and all of that. So there are a lot of use cases for smart contracts. And most banks nowadays, a lot of banks are adopting blockchain technology, and a lot of other major corporations, of course, are also adopting blockchain technology. And of course, at the heart of all of this is smart contracts. The uses of smart contracts are very much enormous. So with all this information, we ask ourselves, what's the role of smart contracts in Web3, in the blockchain? Like I mentioned, they are the engine room, of course. They are the engine room of the blockchain. They actually carry out transactions, verifications, any function you call through a smart contract. Now, remember the vision for Web3 is actually decentralization, interoperability, and user control. So smart contract actually enforces all of this. It's built on a decentralized network, right? So it is also the user control, the power relies on the user, because as long as you have your private key, nobody can access your wallet to do any transaction. As long as you have your private key, nobody can sign transactions on your behalf. So it's very much user, the power lies in the hands of the user compared to our regular Web2 space, where, for instance, a particular website will have to hold all your information, including sometimes your ATM details with the PIN and all of that, which, of course, most of us, like myself, I don't find that funny at all. But that's how it is. But basically, in the decentralized system, we don't have to worry about all of that. All the power lies in our hands. So smart contracts actually play the role of critical role in realizing the vision of Web3. Of course, these roles include secure and transparent transactions. Like I mentioned, the smart contracts are immutable, and also they are deployed on the blockchain. So that makes them very much secured, and they are transparent because it can always be verified. Of course, it encourages a trustless system. Like I mentioned, you can actually do business with somebody you don't know and you don't even want to know, as long as the terms and agreement of the smart contract is valid for you. You can actually trust that the smart contract will enhance all the agreements there. Of course, smart contracts have also introduced new business models in the sense that traditionally, I mean the normal Web2 space, traditionally, every business that occurs usually has a middleman, one way or the other. There is always a middleman connecting the buyer and the seller. But with Web3 and of course smart contracts, the middleman is completely eliminated. The buyer can deal directly with the seller and trust that the smart contract will handle the terms and conditions of their deal. So there is a complete elimination of the middleman. And of course, integration with blockchain platforms. Of course, smart contracts are used to integrate with blockchain, including Ethereum, Binance, Cardano, Polkadot, all of them. So they all rely or utilize blockchain technology to actually implement transactions. So let's look at the challenges of smart contracts in Web3. Of course, there are always challenges to every technology. So the first challenge is the complexity of smart contract. Now, of course, to actually build from scratch smart contracts, you actually have to be you have to know how to code in a particular language. There are multiple languages that can interact with with smart contracts rather. So, but you have to learn you need to have a high degree of technical expertise. Of course, you need to know to a certain degree some major languages and how to use them appropriately. Of course, there's also a problem of scalability. Smart contracts, of course, traditionally on the Ethereum, remember, last week in one of the classes, our facilitator talked about layer twos and all of that. So originally, smart contracts on the Ethereum networks are very much expensive and they are very, very much slow. So that's why solutions like Polygon and the rest of the layer twos came up to actually improve upon that. But basically, Polygon is actually built on top of Ethereum. But it was to solve the scalability problem, they had to try to make it such that you can promote faster and cheaper transactions. So scalability, of course, is one of the major challenges of smart contract. But of course, as technology improves, we've seen so many platforms nowadays with very much fast transaction execution rates and also very low gas fees. So as the technology, remember, the blockchain is not that, the blockchain space is still much very, very young, but there have been a lot of improvements to it. Of course, there's also a challenge of regulation. So smart contracts operate outside of traditional legal frameworks. Yes, that means that you can stay in Nigeria and build a smart contract that everybody in the world uses. So normally, different governments will probably have different frameworks for doing or carrying out businesses within their borders. So this has always been a challenge because since the blockchain is decentralized, it means that anybody in the world can use it, can verify it, can do transactions with it. So sometimes these regulations also pose a challenge. Of course, there's the problem of security vulnerability. Now, this security vulnerability usually is human error because humans are prone to mistakes. So, like I mentioned, smart contracts are, to write them, they are complex and you need a high degree of technical expertise. So, if you write a smart contract and you leave a loophole where someone can exploit, a bad actor can exploit, remember, anything you deploy on the blockchain is immutable, so it cannot be changed. So once you are using a smart contract that has a loophole where probably a bad actor can infiltrate and probably cause damage to the protocol or the platform or steal people money or information like that. So usually it is advised that even as a developer, after writing your smart contract, of course, it needs to be audited. They need to test it to ensure that it's not vulnerable. So most times when in the developer space, most times it is recommended to use standard smart contracts. Like for instance, there are already smart contracts that have been audited, some particular functions, some particular terms and agreements. They have been audited and they have been found to be very, very secured. They cannot be, they have no vulnerabilities. Let me put it that way. They have no vulnerabilities. So basically, it is advised to use these standards, like for instance, when we look deeper, although we try other means, but there's a platform like Open Zeppelin. Now, Open Zeppelin has a lot of already pre-written and audited smart contracts. So basically, if you are trying to build something and maybe you need to call a particular function that has already been audited by Open Zeppelin, and of course, it's free and it's open source, you can just go there, get the code from there. Already it's audited, but the context in which you use it might allow for vulnerabilities. But basically, they provide pre-audited smart contracts that you can actually use to build stuff on your own. So those challenges, of course, as the blockchain space is, of course, evolving at a very, very fast rate. And as we move forward, I'm sure most of these challenges would, of course, be mitigated. So that's that for our lecture today. I'll be taking all the questions I can take. If not, okay, still fine. But that's that for our lecture today, please. Okay, I've seen some hands up. All right, Osinachi, please go ahead.
Okay, thank you. Thank you for today's lecture. Yeah, I've been looking forward to your smart contract lectures. Please, I want to really understand the role of smart contract address because I'm aware when somebody is trying to create a token on either of the platform, Ethereum, blockchain platform, most time there's a smart contract address. So I really want to understand what is the function of that smart contract address and how it's different from our individual addresses. Thank you.
Okay, so the smart contract address it serves the same function as our individual address. So our individual address is our space on the blockchain. Your wallet address is your space that holds your information, like how much coins you have, how many NFTs you have. So it's just like your small space on the blockchain network. So that's why once you lose your private key, that space would always be there. It's just that you will not be able to interact with it. So your address, your wallet address is your space. Of course, with your private key, you alone can interact with it. But when it comes to a smart contract, it's quite different. Now, the smart contract address actually holds, just like your wallet address holds your space, the smart contract address actually holds the terms and conditions of that smart contract in that particular space on the blockchain, such that when you want to interact with that smart contract, you need to get the address of that smart contract. And of course, if you are the person that deployed the smart contract, of course, you sometimes, depending on the agreement, you can automatically become the owner of the smart contract. So, but that smart contract, once you get the address of that smart contract, you can be able to interact with that smart contract. Like, for instance, when you say someone wants to create a token, like you mentioned, there's always a function to send token to someone else. There's always a function to check your balance. There's always a function to maybe other things, but basically there will always be a function to send tokens to another wallet. Now, what happens is that once you press your send on your phone or any of your device, your computer, what happens is that you are triggering a function. You are interacting using that address of that smart contract. You are interacting with that smart contract and you are calling a function of that smart contract. Now, this function is going to check for the terms and agreement that was written into the function. Of course, most functions interact with one another. So it checks all of that agreement. If that agreement is met, so if you are sending money to Mr. B, it checks normally, and if you have like a send function, you first of all check if this Mr. A has enough balance. If he doesn't, revert the transaction. If he has enough balance, okay, send so according to how much he's putting in, then reduce his own balance and increase the other person's balance. All of these are all terms and conditions in that function. So once you press your send and you're calling that function, automatically it checks all those conditions. If it is met, then the smart contract automatically sends your money, as in you've approved the smart contract to send your so amount to so person. So basically, the address of that smart contract is what you use to interact with the smart contract, like to call the functions in the smart contract. So that's the address. I hope I answered your question.
E- Yes, you did, sir. Yes, you did. And also, I just wanted to know, since smart contract is like immutable, it cannot be changed. I've I've come across a section in the smart contract when I was going through it that where I think I saw ownership. You can change ownership of a specific smart contract. I don't know how possible is that. I just want to be sure of it.
Remember, we said the smart contract holds terms and conditions. So if one of the terms in the smart contract was that you can change the ownership of the smart, or you can change the owner of the smart contract, then of course, if you call that function, if you click a button to change owner and you call that function, of course, if it checks for whatsoever it needs to check, normally it will check if the person calling the function is actually the owner of the smart contract, because only the owner can actually authorize or release or relinquish ownership to another person. So if it checks if it's the owner that is calling the function, okay, fine, that check has passed, then automatically the address of the person you are transferring the smart contract to, it's going to check, okay, is this address a valid address? If it's a valid address, okay, pass. So then transfer the ownership. Normally, once you transfer the ownership, the person calling the function, which was the former owner, of course, there'll always be a term and agreement to remove ownership from the person, because if you do not, that means both of them will have ownership. So you have to take the ownership. It depends on the terms and conditions. It could still mean that both of them share ownership. It could still mean that you're taking it completely for another person. So it depends on the terms, and you can write any terms and conditions into a smart contract in the form of functions. So you can agree on anything, and whatsoever you agree on, if the conditions are met, it will call the next function. It will do what you ask it to do. So, Mr. Sheon, your hand has been up.
Good
Mr.
evening.
Sheon, okay.
Yeah, I just want to ask, you mentioned a particular website where audited smart contracts can be gotten the other time. I don't know if you can remind me again of that.
Okay. All right. It's called Open Zeppelin. I think I'll just drop it on the chat. Um, yeah, Open Zeppelin. So, any more questions? Is anybody's hand still up? Um, okay, nobody's hand is up. So I think we
Let's
don't.
just check the YouTube and see. question. Just a minute.
Okay, I'll take questions from YouTube also. I can't see the YouTube from here. So, guys, the material for this lecture, of course, will be released after this call. Always do well to check the classroom, and always feel free to ask questions. You understand? It's only when you ask questions that you understand. So anything that you don't have clarity on, even if it's the terminology, always ask questions so that you get a better understanding. Open Zeppelin website. Okay, so the Open Zeppelin website, Mr. Nicholas, please go ahead.
Okay, sir. Thank you, sir. I want to ask a question whether other layer 2 ecosystems like Solana and Polygon has their own smart contract, or is it readable on EVM, which is Ethereum virtual machine? So I want to know if they have their own separate smart contract and if they have their own virtual machine.
Okay. Thank you very much for the question. Basically, every blockchain has a particular language they interact with. Like for instance, on the Ethereum blockchain, there is a programming language Solidity. Solidity is a fusion of C programming language and JavaScript. So that's the traditional programming language for Ethereum and many other blockchains, especially layer 2 blockchains that are built on top of Ethereum. Now, for a blockchain like Solana actually uses Rust programming language, doesn't use Ethereum like most other ones. And Bitcoin, of course, uses Bitcoin scripts, not particularly a programming language, but a scripting language. So a blockchain like, of course, Polygon uses Solidity. Now, another thing is that on the blockchain, if you write, or for instance, if you deploy a smart contract on a blockchain like Ethereum, you cannot go and call that smart contract on the blockchain like even, let's say, Solana or Polygon. You must always, if you want to call that smart contract from that blockchain, you have to redeploy that particular smart contract. You don't have to change anything. Just redeploy it on the blockchain that you want to use. Because basically, right now, on the blockchain space, they are still trying to solve the issue of interoperability, where different blockchain, different decentralized systems can actually communicate and become truly decentralized. So, but right now, they've achieved the decentralization, of course, the distributed ledger. But now every blockchain, Solana cannot, you cannot use a smart contract, or a smart contract that is deployed on Solana would not function on the EVM, on the Ethereum virtual machine. So while we are looking to the future, and of course, there's been a lot of research and work going on that, hopefully, very soon in the nearest future, they'll solve the problem of interoperability, so that probably if you deploy a smart contract on any blockchain, you can use it any other blockchain. So I hope I answered your question, Mr. Nick.
Yes, sir. Yes, sir. Thank you, sir.
Okay. So any question from the YouTube?
Not at the moment.
Okay. Yeah, of course, Mr. Mushin, exactly. It means that if the problem of interoperability is solved, um, you won't need an exchange to actually swap your tokens, or maybe you can just directly exchange one token for another. If that problem is solved, yeah. Okay, Nicholas again. All right.
Because I read the white paper where Vitaly Buterin was talking about this, that's in this interoperability challenges that in blockchain, that it is hard to solve that it is hard. That's why they are trying to create other layers that can help to solve some the other ones cannot solve. So I don't know how possible it is. I'm just asking.
Can you come again? You were breaking for a while. I think it's my network. I lost you for a while.
Okay, I said there was some statement Vitaly Buterin talked about the interoperability of the interoperability challenges of the blockchain, because that's why they created different layers. These layers they created, that the other layer is meant to solve the other layers that the other layers can't solve. So I don't know whether it is very possible, the possibility of creating, though everything is possible, but how possible it is to create the so that all the networks can connect, relate to each other.
Well, it's very possible when it comes to technology. I mean, if you look back from the era before computers up till today, you understand that there have been a lot of innovations. So it's very possible. Just there's also, it's not just it's very possible. There are a lot of research and work going into it, even up to this moment. So it's very possible. So, Mr. Shehu, please go ahead. All right.
All right. Good evening once again. I just have I was making some research this afternoon about that because I was online on the LinkedIn and all that trying to do the assignment, and then something just jumped at me that I tried to figure out. So I said I would share this evening. This is just it's a riddle to my mind. Since since we are able to use front end, I mean other languages such as React, HTML, CSS, and JavaScript to build the front end, and then we can use other platforms like Ethereum, blockchain platform like Ethereum to build the back end. And then one of the principles of blockchain technology is is the fact that users no there's no KYC per se, so there's no registration that you put your name and everything. Would that mean, for instance, I'm just thinking, would that amount to that if a new user, for instance, want to start to use an application, the person would have to just register with email address, and then the token will be sent to the person's email address, and then the person will continue to use the token to log in subsequently? That's my first question. Then the second question is that if the person is going to be using subsequent token to log in, won't that be discouraging a bit considering the length of the token? You know, because for instance, on the web 2, for instance, you can just know your username and password offhand and use that to log in. But now on the web 3, that is about token, and considering the length of the token, won't that be a kind of clog a bit? I'm just thinking out loud. If this is a possibility, that's 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 what I'm thinking. I don't know if I believe I need some corrections on that. Thank
Yeah, very much right. I like the fact that you're asking your questions. So basically, you don't need the token and all of that. So in the Web3 space, basically you just have a button that will ask you to connect your wallet. So remember, your wallet is unique. You are the one that has the private key. So if if your wallet can sign transactions, that means it has your private key. So once there's the button connect wallet, and you just click the button and it pops up your wallet extension like MetaMask, for instance. Then once it pops that out, now remember I remember I said that in the blockchain you have the power. The power is in your hand. So once your MetaMask pops up, it's not going to connect automatically. It's only going to ask you to authorize, to sign that you are the one that is trying to connect to this website. So basically, once you connect your wallet, it's not as if the person can steal your funds. Once you connect your wallet, of course, it solves the authentication problem in Web2, the problem of username and password. So on the Web3 space, you don't need to create a username and password. You just need to connect your wallet. And remember, the blockchain is, you can trust the blockchain, of course, that this wallet that is connecting, as long as it has the private key, that means this is an authentic wallet. So we trust that once you connect your wallet, you can have access to the website. So you don't even need to create or memorize a password and a username. You just connect your wallet and it solves the authentication problem. A lot of protocols are using it. For instance, if you go to alchemy.com, of course, there's a button like that to connect your wallet. If you go to techfiesta.dev, I think there's something like that also to connect your wallet. So you don't need that username and password in the Web3 space. It's all about your wallet address. The uniqueness of your wallet address makes it possible for you to sign transactions on the blockchain space as long as you have the private key to the wallet. I hope I answered your question. No, your line is breaking. I don't know. Are you? Sorry, I can't get you. Can you come again?
I said I'm just asking you a common question for the sake of those who still want to ask questions. That's what I'm seeking.
You are just asking. I didn't get you. Your line is breaking.
All right. So I said I want to ask another question.
Okay, I can hear you. Yeah. Go ahead.
All right. So now we are talking about the interoperability challenge that that is currently ongoing. Ability of Web3 in the banking industry. Say, for instance,
I don't know if you can hear me. Can you type it because you are breaking? Right now, I can't hear you. But if you can hear me, just drop it in the chat box. Does anyone have any question? While we wait for, I think that was Nicholas, right? You couldn't see. Also, guys, very important point. You noticed in the last week that most of you, while submitting your assignment, you didn't upload anything. There was no link and there was no document, no PDF document. So I don't know. We'll just give you guys just today up till 10 a.m. tomorrow. After then, you won't be able to submit assignment. And I must mention that, of course, your attendance and your assignments are a criteria to be certified. So please go back, check your assignments, make sure that you submitted either a link to the document or a format, a PDF format of the document, please, because most of you are submitting empty. There's nothing there, it's just missing. Okay, Mr. Sharon, I'll take your question.
All right. Thanks for the opportunity. I hope you can hear me now.
Yeah.
All right.
Okay.
Yes. So now, yeah, I was talking about the challenges of interoperability, and then I tried to apply Web3 in the banking industry, and then I said, imagine that you want to onboard a new customer. A new customer wants to be onboarded, and there are how documentation process goes on and all that. I know they may have to struggle a bit on that, but my concern is now that if we have customers, excuse me, that have their own, I'm assuming that customers have their own um token. Let me call it token. Permit me for saying that they have their own token to for identification, and they are on different blockchain networks. One is on Ethereum, another one is on that, and we want to onboard them. How easy do you think it's going to be, for them to be to be onboarded easily on the banking platform, assuming that the interoperability challenge is yet to be solved? Is it that the bank would have to like create a new token for them so that they can onboard them on their own network, on their own blockchain, or how do you think that challenge can be solved?
Okay. Well, from the way I look at it, first and foremost, that's what you just said. Practically, is not possible even in the normal banking system because you can't take somebody from Union Bank and try to. Well, if you're onboarding the person into First Bank, of course, the person has to pass through the registration process and all of that. But then in the banking sector, right? So if you want to implement one or two like onboarding customers in your banking sector. Now, remember first and foremost that the blockchain is anonymous, right? It's only your wallet address that you can use to actually interact with the blockchain. So basically, in this scenario, to onboard people from different other blockchains into your own blockchains simply is to create a wallet address for each and every one of them. So it solves the whole problem of passing through KYC and all of that. So if all of them have wallet addresses, they can interact on your blockchain, they can interact on and of course, creating a wallet address is not difficult and it doesn't cost anything. So it's a win-win from my own view. So basically, it's just to create a wallet address for all your customers. I hope I answered your question. Mboom, please go ahead. Yes, Mboom, you can go ahead.
Hello, good evening. Thank you very much for the lecture. So on the issue of banking sector, I want to ask, if assuming now we decide or the banks decide to adopt this blockchain technology and then creating, can you hear me?
Yes, I can hear you.
Okay, and then creating wallet address for different customers and then interacting from the wallet address, the customers can interact with the bank, maybe do transactions, do whatever they want to do. How will they be able to, assuming there's a fraud, maybe there's a fraud in the sense that someone stole money or just money was lost and paid into an account, how would they be able to trace the owner of the bank or the owner of the wallet address? Since the wallet address, there's nothing like KYC, which is not your customer. How is that? Like my question now is, the summary of my question is, how would they be able to use blockchain technology to track maybe a fraud a fraud case or a victim and all whatnot, how will they be able to use blockchain to track it? That's my question.
Okay. Well, first and foremost, the blockchain is transparent. So any transaction that goes through the blockchain can always be verified, can always be tracked. So in the question of how they would know, so assuming in this context, the bank is creating creating wallet addresses for their customers. Of course, before they match a particular wallet address to a customer, they would have that customer's information before now. So in the case of a fraud, which is not possible to steal money from the blockchain unless the person has access to your private key, or maybe you are relying on a centralized exchange. So if none of those two scenarios is in play, then of course that wallet address is safe. So there's no way an external person can get money from that wallet address as long as that wallet address is on the blockchain. But also in reality, banks actually use blockchain. Maybe not on the customer side, but many banks, they use the private blockchain. Like, for instance, in Nigeria, most banks use Hyperledger. Now, Hyperledger is actually a private blockchain. Of course, our eNaira is actually deployed on Hyperledger. So it's a private blockchain, and many banks use it, but the customers are not aware. So the use of blockchain, like I mentioned, smart contracts and blockchain, it spans our daily life. So it's about the adoption. Every day, more people are adopting it. And I believe that in less than no time, in the nearest future, every protocol, every protocol, every online, anything online have to do with blockchain. But basically, from your question, I hope I answered your question because, like I mentioned, if the banks want to use like create wallet addresses for each of their customers, they will need to match each customer to a particular wallet address they created. So that means they have information of that customer. So if somehow peradventure from anywhere there is a fraud, of course, the fraud happened on the blockchain. So the bank can always trace it. This particular transaction, this time went to this wallet. So they know the owners of the wallet, so they can always trace it. So I hope I answered your question also. Sorry, did you say? What did you say? Sorry, I didn't get it. Okay, so I'll take one more question because of time. Nicholas, all right, last question for the day. Go ahead.
Okay, sir. So when you are saying something about the immutability of the blockchain, I want to understand. If, for example, according to what the other person asked, if, for example, you paid in some money, maybe you do a transaction using someone's contract address, and you send it in, but you made a mistake in the actual contract address you wanted to send the money to. Now the money is now in the blockchain. But when they now verify the person, when they verify the person that you send it in, how can they reverse the money? Because the immutability of that blockchain, the immutability of the blockchain cannot allow you to reverse the money back to the person. And you don't even know the person you send the money to, because what you will see is only the contract address of the person. So I want to know exactly what is it, because sometimes if I want to do some transaction using, if I want to withdraw or transfer someone, there's a warning they usually say that make sure that the contract address is correct before you send. So if eventually you are not paying more attention and you send, how are they going to reverse your currency back? Thank you, sir.
Okay. Well, the simple and honest truth is that there is nobody that can reverse it for you, except on, like I heard you were saying, the contract address. So if it's a smart contract, you send it to, and probably with the aid of major players in the smart contract security space, they are able to track that smart contract to know who actually deployed the smart contract. Then maybe the person may offer to send you back your money. But if you are sending it to another smartphone times another wallet address that is not the one you intended to send, you are at the mercy of the receiver. He or she may choose to reverse your money or not. Okay. Now you ask, how would you be able to communicate with that person? Of course, it's not only transactions you can do on the blockchain. You can send messages, but a lot of people don't do that. You can actually send a message to a wallet address. So you can actually message the person, and if the person pities you and sends your money back. But the worst scenario is if you send money to a wallet address or a contract address that does not exist, that money is lost. I don't know if you get me. Because the terms of your token would only check if you have the amount you want to send, and if you have that amount, send it. So it's not going to go and check, except is maybe the smart contract, or no, most tokens won't even check. They will just send it. Then if the address that you are sending it to peradventure does not exist, that money is lost and nobody can get it back for you. That's why it's always advisable to always double check your wallet, their wallet addresses you are sending money to. Most times you don't need to type it, right? So you can have now on most mobile devices and most websites, they actually give you an option to scan. So if you feel you're not comfortable with to copy and paste the wallet, always scan the wallet. That way you can never be wrong. So any more question? I'll take one more. I said I'll take one more earlier. So I'll take just the last one, then I'll call it tonight.
Yeah, there's a question in the meeting.
Sorry, what did you say?
He said, actually, there's a question in the chat where I asked how funds in a deceased wallet can be transferred to next of kin.
What did you say? Sorry. Sorry about that.
Yes, I said, oh shit.
I didn't get
I'm
you,
just
please.
trying to if there's provision or possibility for funds in this wallet to transfer to next of kin.
Your line is actually breaking. I didn't get you. Can you hear me?
Yes, I hear you. Loud and clear.
Okay, let's try again. Please go ahead.
Yes, I said, is there a provision like that is factored into consideration whereby a deceased funds, can
Is there provision for? I think you should type it because I didn't quite get you. That was Nicholas, right? So, Mr. Nicholas, please do well to maybe drop it on the chat box because your line was.
Sir, it's not me, sir. It's not me.
Oh, okay. Let's see. I can hear you now. All right. Deceased fund. Okay. If you have the deceased private key, you can always retrieve the fund. But if you don't, the money will stay on that wallet forever. I hope I answered your question.
Yes, thank you.
All right. So guys, do well to check the classroom. The materials will be shared on the classroom. And also, of course, our assignment will also be shared on the classroom. But please go back and ensure that you actually submitted a material in the previous assignment, because your assignment, your attendance, of course, will determine your certification. Of course, this week we'll be also having another bootcamp. Congratulations to last week winners, and I hope we all learned something good today. So that's it from me. Thank you very much. The attendance link was shared earlier. Okay, I'll just get it. All right, so that's the attendance link.